The next steps in the instructional design process, steps 4 through 6, involve conducting a secondary instructional analysis once you have identified what context you want to define, and then revising your goal and, if needed, and then developing a content or a concept map if needed as well. So that is part process. It's the second part of analyze. And again, it's really important because sometimes you develop a goal, you identify a context in which learning the goal has meaning, and then you realize, oh, wait a minute, my goal has to change in order for the context to become part of the goal. And that might be important at some point. And why that's important is because if the context does need to be part of your goal, then you need to ensure that you have included some resources so that students can acquire those skills associated with that part of the goal. I'll give you a perfect example. You might have some skills associated with writing, with language arts, that involve, writing a particular way and writing well. And as part of the context, you decide that you want to have your students develop some kind of a web-based entry, data entry or presentation, I should say. Like, for example, having students edit or create new Wikipedia entries or edit existing entries. Well, if that's the case, and that becomes part of your your context, then the goal needs to change probably to reflect skills that might involve being able to successfully present material online. So now your writing goal includes a component to it that involves web-based publishing. And that might be something that the students have already learned how to do and do well, in which case all of that is prerequisite. But it's important to include your design documents as you move forward. So that's why it's important to reanalyze everything once you've identified your context. So as I indicated, you revise your goal in this phase. You develop a flow chart and a concept map at this phase, and that's really important because I think it's super important when you develop instructional strategies that part of the introduction to any good new learning experience includes the presentation of a large kind of conceptual map. What am I learning how to do right now, and what did I learn coming into this, and what is going to happen after I leave, and that kind of thing. I tell you, if math would do that, if all math teachers would do that, students would be able to acquire math skills much more successfully. And I could probably say the same thing for other things as well. But I thought it was a travesty when I got into graduate school and I learned that I was taking physics classes at the time, and I learned how important trigonometry was for learning about inferential statistics and also learning about some fundamental derived physics equations. And I had no idea. I learned trigonometry in high school because I had to learn it and because it was just a set of skills that came next in the book. And I did not once did anybody connect what I was learning how to do with anything that had any meaning or substance or application in anything I would learn later or might learn later. And that's just kind of a travesty, and it's not best practice. So the flowcharts and concept maps are important, and I included some resources on the course website about how to develop concept maps. And I must say that an awful lot of students in this project submitted concept maps that just looked like the one that I did, and that didn't make any sense to me because the concept map that I provided regarding the organization of life was something I used to present to my students when I taught biology. There was a structure and a reason why it was all these concepts that were provided in a circle from smallest to biggest. And there was an absolute sort of structure to that. And it was circular because what started as a question, what's bigger than than the universe, ended up with a similar question by the end of the circle, and that's what's smaller than a subatomic particle, And so there was a reason for me arranging that, and many of the concept maps that were provided or presented in this project had did not have that kind of a relationship between concepts. And remember, a concept map is a picture that depicts the relationship among and between different concepts. And if it's hierarchical, then that's the way that it needs to be structured. And if it's circular or cyclical or process, 1 step, 2 step, 3 step, then that's the way it needs to be depicted. Once you have done all of that, then it becomes pretty easy to look at that and begin to identify, well, what are the goals what are the objectives that need to be learned in order to learn the content that is depicted in the concept map and within the goal. Now, the notes at this step involve creating a flow chart that shows the relationship among and between the overall goal, what the main goal steps are, and then what needs to be learned in order to accomplish those goal steps that, once they're learned, contribute to actually accomplishing the goal. And I understand and I know that I did not provide enough examples and feedback over this in the course notes. There are other resources that I hope to have online eventually that can help address that. But for now, I included a model of what a flowchart might look like. I talk about the difference between what a prerequisite skill is, what a content bridge is. Content bridges are important to include in flowcharts because they provide an indication that you as a teacher need to present some material to students to help them understand and learn something, but that you have no intention of them actually using that information on a test, or there's no skill associated with that. You just want them to be able to learn that so that they can learn other things. And I'll give you a perfect example in the slide to follow of what a content bridge might look like. I took, and I know that the font and the text is probably hard to read, but I took the project that we're working on and I took a tiny piece of the goal. So I said, okay, what if I'm working with my client, my teacher, and part of the goal is that she wants her students to use a microscope to identify single-celled organisms in a water sample and determine if the organisms are algae or protozoa, which would be plant versus animal cells. Okay, that goal needs to be broken down into subordinate skills. Students need to learn one thing before they can learn another, before they can learn another, and that. So in this example, I have preparing slides as a goal step, and then distinguishing animal and plant cells as another goal step. And I've worked with kids enough to know that just being able to prepare wet mount slides to be observable under a microscope and being able to identify and locate anything on that slide, that is a goal step. That is a fundamental thing that kids need to learn how to do, and it involves a collection of procedures, processes, and also motor skills to successfully do. So you'll notice the subordinate skills for that, preparing a slide, goal step number 1, involves preparing the slide mounts and also being able to identify objects on the slide. And it's possible when you're communicating to students about using the microscope and the steps involved in identifying things under a microscope that you might need to have the students know about some specific parts of the microscope. For example, if you say to them, well, in order to locate an object on a microscope, the very first thing you need to do is to, first of all, lower the stage using the coarse focus knob, lower the stage all the way to the bottom. Well, that's the first step, and then you put the slide on, and then you go from there. Well, I just used some terminology that they might not be familiar with, students might not be familiar with, and that involves the stage and the coarse focus knob. So I would definitely include those as subordinate skills that need to be learned in order for them to learn the next skill, which is being able to actually locate and identify something under the microscope. And I would say, as a biology teacher or as a science teacher, that I think it is worth learning the parts of a microscope. And I say that because the culture of my classroom was one that students use the microscopes all the time, and that I would be giving them directions and structure to using microscopes that involved the use of language that they just needed to be comfortable and familiar with. That was part of the class. Now you'll notice that the next goal step, distinguishing animal from plant cells, number 2, in order to do that, students need to be able to identify certain cellular structures. And And basically speaking, plant cells have cell walls, and animal cells don't. Other types of cells have cell walls too, like fungal cells. But cell walls, they generally have large central vacuoles. Not always, but generally. And many plant cells also include chloroplasts that have the green chlorophyll in them. And animal cells don't have those, generally speaking. So there's some bacteria that might break the mold, but then we might not call those animal cells. Anyway, you'll notice one thing that I did at the very bottom on the right is that I put labeling different plant cell parts as a content bridge, and what I am suggesting by doing that is that I have no intention of testing my students over all of those organelles, being able to identify them all, not labeling a diagram of them. That would not be of value to me as a science teacher. I would say I do not want to spend the time, energy, and effort having my students learn how to identify all of those different organelles, because I have a sneaking suspicion as a teacher that if we work with cells enough, we work with microscopes enough, that a lot of that information will become very common to my students at the level that I'm teaching them. That is so super duper important at the level that you are addressing them. This woman is teaching like what, middle school, upper elementary. For crying out loud, a kid does not need to know the difference between rough and smooth endoplasmic reticulum in 6th grade. If you are going to spend some time, energy, and effort having them learn that, then in my opinion, you just wasted a lot of time. If they're going to be learning about cells in future coursework like college biology, you know what? They're going to learn that then. Not appropriate at that level. And I would say, here I'm going to editorialize for just a single moment, I would say that 90% of the content that teachers try to help students learn, how to identify, label, whatever, from kindergarten through 12th grade should be content bridges and not outcomes. And I think that's an area that we're really falling short on as enlightened educators. There you go, my soapbox for the day.